Learn oilfield stuff. Hey there! Welcome back to Learn Oilfield Stuff, the ultimate channel for all things related to the oil and gas industry. Our expert team is dedicated to bringing you informative articles in a fun and engaging way. So, if you're ready to take your knowledge of the oil field to the next level, hit that like button, share this video with your friends, and don't forget to subscribe to our channel. Hey guys, we're back with another informative video on drilling fluid reports. In this episode, we are going to dive deep into the parameters of yield point, gel strength, and pH, so sit tight and let's get started. Let's begin with yield point. This parameter is measured in pounds per 100 square feet, and it's obtained from the viscometer. Yield point is a measure of the attractive forces within the mud under flowing conditions. It's influenced by various factors like surface properties of mud solids, volume concentration of the solids, and concentration and type of ions within the fluid phase. The yield point is measured by either of these two methods. YP equals 300 revolutions per minute reading, PV or YP equals 2 by 300 revolutions per minute reading, 600 revolutions per minute reading. This gives a Bingham yield point which is generally higher than the actual or true yield. However, the Bingham model doesn't give particularly good readings at low shear rates. Now, let's talk about what causes high viscosity resulting from high yield point. There are 5 main causes: the introduction of soluble contaminants, the breaking of clay particles, introduction of inert solids, drilling of hydratable clays, and insufficient or overtreatment of mud with chemicals. Treatment for increased yield point can be controlled by chemical action, but the reduction of the yield point will also decrease the apparent viscosity. Speaking of reduction, let's move on to our next parameter: gel strength. This is a measurement that denotes the thixotropic properties of the mud and is a measurement of the attractive forces of the mud while at rest or under static conditions. Gel strength is also measured in pounds per 100 square feet and is affected by flocculation. To measure gel strength, the mud is stirred at high speeds for about 15 seconds with the viscometer and then turned off, or put into neutral and then waiting for the desired period of time, i.e., 10 seconds or 10 minutes. The maximum dial deflection before the gel breaks is then recorded in lb, 100 square feet. For a drilling fluid, the fragile gel is more desirable. In this case, the gel is initially quite high but builds up with time only slightly. This type of gel is usually easily broken and would require a lower pump pressure to break circulation. Now, moving on to pH, drilling muds are always treated to be alkaline. The pH will affect viscosity, and bentonite is least affected if the pH is in the range of 7 to 9.5. For minimizing shale problems, a pH of 8.5 to 9.5 appears to give the best hole stability and control over mud properties. A high pH, 10+, appears to cause shale problems. Also, the corrosion of metal is increased if it comes into contact with an acidic fluid. From this point of view, a higher pH would be desirable to protect pipe and casing. Carbon dioxide corrosion can cause severe pitting and cracks in fatigue areas. If moisture is present, CO2 dissolves and forms carbonic acid. This causes a reduction in pH, which makes the water more corrosive to steel. So, these are the 3 most important parameters that you need to keep in mind while evaluating drilling fluid reports. Don't forget to hit that subscribe button and turn on the notification bell to never miss a video. Thanks for watching, and see you in the next episode.